Hello viewers, our today's topic is dimension. Now, what is dimension? The definition of dimension is the power of different fundamental quantities in a quantity is called dimension. Here the keywords are fundamental quantities, quantity, and power. Fundamental quantities are 7 in number: length, mass, time, electric current, temperature, amount of substance, and luminous intensity. Now, what are the derived quantities? Force, displacement, velocity, acceleration, etc. All other quantities. So, dimension means actually to express this force, displacement, velocity, acceleration, and all other derived quantities using these fundamental quantities, these 7 fundamental quantities. This is all about dimension. Let's proceed forward. We are going to start our today's discussion with dimension of velocity. Here I have written dimension of velocity equals to L T inverse 1. This is the way we write dimensions. L stands for length and T stands for time. We know velocity v, it is a vector, equals to displacement, it is also a vector, divided by time. So now how we will determine the dimension of velocity? See, velocity equals to displacement divided by time. Now, we know the unit of displacement is meter and unit of time is second. So we can write meter divided by second. Here meter is the unit of length. Meter is the unit of length and second is the unit of time. So we can write length divided by time. So it is L T inverse 1. So we can say that dimension of velocity is L T inverse 1. Done. Now, dimension of acceleration. We know dimension of acceleration. Here I have written L T inverse 2. L stands for length and T stands for time. Acceleration A, it's a vector, equals to velocity divided by time. Now, unit of velocity is meter per second and unit of time is second. So acceleration equals to velocity divided by time. Then we can write meter per second divided by second. Then we can write meter divided by second square equals to m divided by s square equals to, as meter is the unit of length, so length, second is the unit of time, time second square times square. So dimension is L T inverse 2. So dimension of acceleration is L T inverse 2. Proved. Now, dimension of force. Here I have written the dimension of force equals to M L T inverse 2. M stands for mass, L stands for length, and T stands for time. Now, we know F equals to ma. M mass and A is acceleration. Unit of force Newton and unit of acceleration meter per second square. And unit of mass is kg. So, what is the unit of force? It is Newton. Newton can be broken into kilogram, meter and second. Here Newton equals to kilogram multiplied by meter divided by second square. So, it can be written as kg meter second square. Now, let us show about the dimension of force. F equals to ma equals to mass into acceleration equals to, as the unit of mass is kg, so it's kg into meter divided by second square, which is equals to Newton. We can write this here. Newton equals to kg meter per second square. Then we can write kg meter second inverse second square. This is equal to Newton. And then we can write mass, length divided by time square. So it can be written as M L T inverse 2. So dimension of force F equals to M L T inverse 2. Proved. Now, dimension of work. I have written already here. Dimension of work equals to M L square T inverse 2. Now, how we can determine this? We know work equals to force into displacement. Unit of force Newton, unit of displacement meter, and unit of work is joule. Let's see how we can determine it. W equals to Fs equals to, we know the unit of force is Newton, so it's Newton into unit of displacement meter. Now we will break Newton like previously I have shown you. Kg meter second square, it's equals to Newton into meter. The same meter here. Then kg meter multiplied by meter, meter square second square equals to, now I can write mass into length square, since it's meter square, divided by second square, so it's time square, equals to M L square T inverse 2. So dimension of work equals to M L square T inverse 2. Now dimension of power. I have already written dimension of power equals to M L square T inverse 3. We know power equals to work divided by time. Unit of power is watt or joule per second. Unit of work joule. Unit of time second. Now let us determine the dimension. W by T equals to work per time. Now we can write here joule per second. Again we can break joule into Newton and meter divided by second. Now we will break Newton. Newton equals to kg meter second square, then multiplied by meter, then divided by second. So the result is kg meter multiplied by meter, meter square, second square multiplied by second, second cube. So mass into length square divided by time cube. So m L square T inverse 3. Now dimension of pressure. Dimension of pressure equals to m L inverse 1 T inverse 2. Let's see how. F P equals to F by A. F is force and A is area. Both are vectors. Unit of pressure is Pascal or Newton per meter square. Unit of force is Newton. Unit of area is meter square. Now let's see how can we derive the dimension. Force divided by area equals to Newton divided by meter square. Now we will break Newton. Kg meter second square multiplied by 1 by meter square. If we write it together, then kg meter square meter, so meter cancel, meter below into second square. Good. And the result is mass, length, time square equals to m L inverse 1 T inverse 2. So dimension of pressure m L inverse 1 T inverse 2.